Considering the graph above, the dashed line represents the man on a motorcycle, the dotted line the bird. The bird flew into the man according to the graph. What were the directions of the movement or velocity of each of these items before and after the collision? Explain your reasoning. Well, momentum is mass times velocity. Mass isn't going to be negative. We can see the bird started with a negative momentum and ended with a positive, where the man was positive the entire time. So I would say that the movement of each object before and after the bird initially was negative and finished positive. The man was positive and finished positive. Assume the man had a greater mass than the bird, which the bird or man or neither had a greater. For change in momentum, we know change in momentum is impulse, which is force times time. They're going to have the same change in momentum. For change in velocity, if you increase the mass, you are going to have a decreased change in velocity. So for any greater mass, you'll have less impact of the velocity. So since the man had a larger mass, the bird's going to have a larger change in velocity. Force applied on them from the other object. Force applied on them from the other object. Newton's third law states that the force from an interaction between two objects is going to be equal but in opposite directions. They're going to have the same force between them. Newton's third law. All right, new graph, new situation. A kid is running through a supermarket. He sees a cart loaded with heavy groceries that's slowly rolling forward. He jumps onto the cart, collides into it, and rides forward. The graph above shows the velocities of these objects through the thrilling adventure. So this is a velocity graph. Which object had a greater mass based on the graph? Explain your reasoning. Again, a larger mass is going to have less of a change in velocity than a smaller mass. Think of a car hitting a bug driving down the highway. Car doesn't really have a change in velocity, where the bug would have a huge change in velocity. So a larger mass, less of a change in velocity. So which one has a greater mass? It's going to be the one that had the least change in velocity. So the cart is going to have the greater mass. If the boy cart system is closed with no external forces acting, what must be true about the system's momentum before the collision and the system's momentum after the collision? Well, if it's a closed system, there's no external forces acting, and that means the momentum is going to be conserved. It's going to be the same. Total momentum, not individual objects, but total momentum of the system is conserved. The time for this collision is very short. A student says, since the time for this collision is very short, and then the internal forces involved in this collision must also be very small. Well, if you have very small forces in a very small time, you would have a very small impulse. Force times time is impulse, and just because you have a small time does not mean you have a small force. Reducing the time usually increases the force to maintain that impulse. For this situation, draw a displacement versus time graph for the grocery cart. So if we draw a graph that has displacement and then we have time, the displacement versus time graph, the velocity will be our slope. So we're going to have a constant slope initially, and then once that impact occurs, we're going to have a new slope that is a new constant, because we have two constant velocities, the velocity from before and the velocity that's after. That little intersection would be when the moment in time the impulse occurred or the collision occurred. Football player A tackles stationary football player B. Player A was originally traveling at 10 meters per second. After tackling player B, player A is now traveling at 5 meters per second. If the collision was perfectly inelastic collision, players stuck together, how does player's weight compare to player B's? Do not get too hung up on, well, perfectly inelastic or inelastic. Inelastic just means that your kinetic energy is not going to be conserved. Do not get overly hung up. Let's just set up the problem. We've got Player A, mass times velocity, plus player B, mass times velocity, is equal to the combined mass, A plus B, times velocity. So it'd be ma, mass of A, times 10, plus mass of B times 0, is equal to mass A plus mass B times 5. If we distribute the 5 into the parentheses, we're going to get 5ma plus 5mb is equal to 10ma. Subtract the 5ma to the other side. 5ma equals 5mb. That means they have the same mass. If they have the same mass on the same planet, they have the same weight.